Hello, everyone. Good evening. Thanks to be here with us tonight. Let's wait a few minutes and then we can start with our webinar.
Le déluge? Ouais, c'est vrai que ça se charge de noir là. Hein.
I think we can start. I give the floor to Camille for a brief presentation of our project and the framework in which we held this webinar.
Thank you, Sarah. I hope everyone hear me well and see actually my screen. So my name is Kamil Levitovic from Cosmetic Valley, which is a leading global perfumery and cosmetics network. And we are the coordinator of the French sector and also the coordinator of the project ACT4Cosmetics. So I'm pleased to introduce you this new webinar. And before I let the floor to the speakers, I will briefly talk about our program, ACT4Cosmetics, to which the webinar belongs. So ACT4Cosmetics means improve interconnected innovation ecosystems, supporting actions for citizen awareness, end-to-end transition in the entire cosmetic value chain. This project has the aim of recognition and be a voice for European founders, demonstrating that the cosmetic industry is a sector of innovation, to gather and bring together players from all sectors to define and discuss about major issues in the cosmetic industry, and to innovate with building consortiums on innovation topics in the following areas, such as green transition, digital transition, and societal transition. Actually, we will have two working groups about the management of water and also the eco-conception of packaging during this year in 2025. So what's ACT4Cosmetics' goal with those working groups? Actually, the consortium will choose with you an innovative topic for each working group. A diagnostic is actually diffused to our network and is also and those questionnaires are actually available on our website act4cosmetics.eu. Then ACT4Cosmetics suggests a first draft to bring actors together, organize some information meetings and workshops as many times as needed, and then we redact a concept note that we will send to the European Commission. ACT4Cosmetics will also help all the consortia that will be developed in the case of those working groups and find the right European opportunity, and at the same time it also promotes all the thematics to the European Commission. You should register on ACT4Cosmetics website, but why? Actually, registering on our website will also offer you several opportunities, the new working groups that I mentioned, of course, but also the visibility of your internship or thesis offer on our website. We have a dedicated platform for this. We also have a subscription to our newsletter to keep abreast of current trends in the cosmetics market and the latest development and activities within our project. And finally, you will also receive a watch on financing European opportunities every 2 months. So if you are still interested, of course, please subscribe to the website. Thank you very much for hearing my message, and I let the floor to the speakers.
Thank you, Camilla. My name is Sara, and I am project manager for cosmetic industry at REI, the marketing agency in Lombardy region that manage the Lombardy cosmetic cluster. So it's time to start, to leave the floor to our speaker. First, I introduce Alberto Ceselli, Associate Professor in the Department of Computer Science at the University of Milano, and also serve as an officer at the Department Industrial Advisory Board. He concluded research periods at various European institutions and is engaged in both academic and industrial research, teaching, and technology transfer in the field of optimization, mathematical program, and prescriptive data analytics. So I left the floor to Alberto for his presentation. Thank you.
Thanks, Sara, for the nice introduction. I'm really glad to be here, participating to this seminar and sharing these presentations with Francesca Saraceni, who's such a nice and bright researcher from industry. I'm really glad to do this presentation together. So let me share my screen. Yes. Very good. So Sarah already introduced my duties and my interests. I like to stress that the main point, keeping together my interests, is models and algorithms for optimization, and in particular, as Sarah said, prescriptive analytics with applications to various fields, such as logistics, telecommunication networks, and of course, cosmetics. So I like to start the talk with perhaps the most common question in talks about artificial intelligence applied to any sector, which is what we need to consider as an intelligent task. So the question indeed was the focus of the research of several fathers of computer science, one of them being Alan Turing, right, who first faced the issue from a theoretical point of view. So the initial question was, is there really some task that a human can do and the machine cannot? And from a pure theoretical computer science point of view, the answer is yes. So from a pure theoretical point of view, that's the answer. So we cannot have intelligent machines, period. And so that would conclude any talk about artificial intelligence, right? But indeed, that's not only the beginning of the tale, because the actual answer needs to be given from a different point of view, not from the point of view of theory, but from the point of view of what we can do. So from the point of view of behavior of a machine. This was already clear to the fathers of computer science, and one of the first attempts of understanding if a machine was giving an intelligent behavior is again from Turing, with the famous imitation game. So without going into the details, the idea of the imitation game was to make a test of a human player against another player acting as in a chat on a different PC, from a remote PC, and so the human player does not know if at the other side of the PC it was a machine to answer to the chat, or a human being, and the machine was considered to be intelligent if it was able to fool the player, making him or her to think that the chatting was done with a human and not with a machine. So our expectations about what is meant to be an intelligent task changed during the years. Back in the 50s, it was playing simple games like chess. Then it began being able to process natural language, then artificial vision, autonomous driving, up to the most recent applications like custom medicine or personalized product design in cosmetics, as we are talking about today. How did we change these expectations? Because machines didn't change since the 50s. Their structure is the same. If they were not able to perform intelligent tasks in the 50s, they are still not today, in a sense. My claim is what is changing over years are not machines, but the way in which we instruct machines in performing tasks. Or in other words, the models that we use to tell machines how to behave. And let me go to the roots of these concepts and back to a straight, say, discussion about what is a model. So on the left, you have a picture of a real system, a very complex one. So the beginning of a volleyball match. You have the player hitting the ball for the first time. I claim it to be complex because it's involving lots and lots of features, like the jump of the player, the strength of the hit, the size and the weight of the ball, and so on and so forth. So one may be willing to represent the behavior of such a system in a computer, and the task may be very, very hard. However, if instead I have a specific decision task in mind, like deciding if the ball will hit the field of the other team or not, then I can focus only on the relevant details of the system to be modeled. And therefore, I can drop lots of features which are irrelevant. So on the right, indeed, you have something. That's kind of a simplification, but I guess it's giving you the idea. You have what we call a symbolic model for such a system. It's just describing the trajectory of the ball. I call it symbolic because it's expressed in terms of a mathematical equation. So in terms of symbols. So numbers and variables, right? Great. That's, as I said, what we call a symbolic model. Building up symbolic models, which are built by the logic of the modeler, in this case, using the laws of physics, is not the only way of building models, because with a kind of short circuit, we can use machines to try to build models, or at least rebuild part of models. And the approach that we can use, the alternative approach, is the so-called data-driven approach. So instead of putting symbols in our models, we look at examples. So in this case, there might be examples of trajectories representing balls hitting the player, the field of the other team or not, and we use algorithms in a machine to rebuild the part of the model we don't know by trying to fit the model to these specific examples. That's the field that we normally say outline as machine learning. Okay, so indeed these two ways of modeling look at machines in very different ways. So the symbolic way of modeling look at computers as deductive machines. We give them input data and a description of the logic of the task we wish to accomplish, and we ask the machine to give us as an output the result of our analysis. The data-driven approach instead look at computers as inductive machines. We give them input data and output results, and we ask them to produce as an output the logic mapping input to output. So and I won't go into the historical perspective. I already did a lot. There were say moments in history in which one approach or the other was more promising in the artificial intelligence fields. Overall, we went through good and bad periods. So with say alternate results. Just to give you an example of what we can do with a symbolic approach, I already gave you. So build up descriptive models like for trajectories. Another example is that you see on the bottom right this example. which is a bit more involved. And also in this case, as you can see, it's a model composed by symbols, data, variables, equations, inequalities. And say this is a description of a prescriptive problem, just to go directly to the meaning of placing in the best possible way a certain number of resources on a network. That's it. Let me also give you some example about the data-driven approach, and in particular one field of data-driven approaches, which is a so-called connectionist approach, which is trying to say rebuild models by thinking to them as simulations of the human brain, roughly speaking. So in terms of neurons and synapses connecting them. So these types of models, which use as a fundamental computing unit, the one you see on the top left, the so-called perceptron. Perceptrons are very easy to describe. They are components which take as input numerical values. They combine them. They make a weighted sum of them, in a sense, where these weights are parameters. Okay. Then they compare the results with a certain function. It might be even a simple threshold, and output another number. Very simple computing units, which on their own are not so expressive, but when you build networks of them, so-called neural networks, they can start be useful in solving data-driven modeling tasks, like classification tasks. This is a very simple framework. So let me also mention that on this idea of building neural networks, there have been many improvements over the years. One of them is the so-called field of deep neural networks, which is whose idea is pretty simple. So a perceptron is this unit described by 3 parameters. Great. Let's build the networks with a huge number of them, connected in layers with many perceptrons per layers, many input, many output, and that's it. In such a way that these networks will not have 3 parameters anymore, but billions of parameters. The second type of advancement I like to introduce, and it's also an introduction of what Francesca will detail more in her talk, is more structural and is about graph neural networks. So I describe these computing units as having a numerical input and performing simple aggregation of numbers, but actually you can have more involved structures as input, like a description of a molecule and more involved computations, like a computation described by a graph. So more computing units will run in parallel and exchange informations. Great. So that's, I guess, still by looking at these easy models and try to understand how can we reach the result that we see from current technologies, makes a huge gap, right? So we would like, in a sense, to understand where are we in the say process of obtaining reliable technologies out of these models. So here in this slide, you see the famous Gardner hype cycle. So it is a kind of pattern, kind of trend every technology goes through. You have time on the x-axis and say expectations about the technology on the y-axis. So we start by research and development in a lab setting. We go through a peak of expectations, then through what we call the valley of disillusion, and then only finally towards a plateau of productivity. That's where reliable technologies are developed and deployed and become productive for industry. So a pertinent question would be, okay, where are we now concerning the artificial intelligence technologies? It would be very difficult, I guess, to answer. So if we think to maybe generative models, I would dare to say we're kind of around here. I don't know, a little bit before the peak, after the peak, very hard to tell, right? However, once again, if we don't look at AI models as a whole, but we try to understand the different types of models, we can get more accurate answers to this question. So let me cast the AI models in a decision-making perspective. So I'm going to use this sequence of decision levels, which are often used to describe the type of approach in decision support systems. So these levels go from information, say from data, up to more, say, refined grains of decisions to take. So the first level, the one more near to data, is called the descriptive analytics layer. Models belonging to this layer try to answer a question like, okay, what happened in the past? Are we able to reproduce in a computer the behavior we observe on a certain system? On the next level, you have the predictive models, which helps you in forecasting. So knowing what happened in the past, are we able to predict what is going on in the future? And the last level I sketched is that of prescriptive analytics or prescriptive AI models, whose aim is to, okay, tell, I have past data, I have some objective in mind, I have some target in mind, which actions I need to perform to reach my target. We can also put generative AI in this decision-making layers for sure, but generative AI is only one of them. Okay. So let me give some example of applications we developed at the two extremes of these layers. Okay, the descriptive layer and the prescriptive layer. Concerning the descriptive layer, this is an application developed in the context of a previous work in collaboration with companies in cosmetics industry. And it is not about the design of products, but is about the management of warehouses, automatic storage and retrieval system. This is an automated warehouse of one of the partners of the project. And this is a screenshot of a simulation model we built. Their automated warehouse has a stacker crane moving boxes from the outside of the warehouse to the shelves of the warehouse, back and forth, say. So we were able to reproduce in a computer simulation the behavior of their model, but we could do also more. We applied what we call a reinforcement learning technique. So what you need to do to manage this warehouse is to take actions whenever a new box needs to be stored or whenever a new box needs to be picked up from the warehouse. So say this agent needs to take the best possible action every time, depending on the context, which is given by the current situation of the warehouse, like placing the box in the middle of the warehouse or to the sides or whatever. Taking the best decision is clearly difficult, but using the simulation model, we could train a virtual agent, which was trying different actions at different points in time, looking at the effect of each action on the simulation and correcting the actions depending on their outcomes. Once the agent is trained on the simulator, we had as an output a table, say linking, mapping the situation of the warehouse to the best action to do. That became our model for decision support. As I said, it's difficult to try to understand the positioning of technologies in this curve if we look at them independently on the decision level we target. However, if we target the decision level like this one, so descriptive analytics and optimization of actions, then the technologies we have are pretty much advanced. These are well understood. We are already in the plateau of productivity concerning these types of models. Let me go through another example. As I said, this is going to cover the other extreme in these layers to support decision, prescriptive analytics mostly. This is something we are currently experimenting in our lab. It is a framework for supporting decision in the design of products. So assume you have already designed a product, a molecule, and for a certain market. Now you wish to deploy, to use the same molecule on another market, but for some reason you cannot. For instance, some ingredient that you have used in your product is blacklisted by a regulatory of the new market. So you need to evaluate and choose other options, modifications to your product. That's a very hard task to do, as you may know much better than me, actually. So what we plan to do, what we are currently trying to develop, is a framework for supporting human decision, not for replacing them. So our framework has a human in the loop by design, and is using different models at different stages and integrating their tasks. So it's using pure data-driven models for understanding similarity scores, perform functional clustering of similar products, and so on. At its core, however, has an optimization mathematical engine, which is using symbolic models to compute optimal substitutions pattern and perform filtering. That is, among all the combinatorial way of possibilities you may have to replace one ingredient with other subset of ingredients, this mathematical engine is able to compute the minimal actions that can be done to perform these substitutions. This is integrated with other types of models, also generative ones for data presentation and say preference collection and other types of tasks. However, as always, a human in the loop. So using it in iterative way for supporting decisions. So just to give you an idea on the type of results, the behavior we can have, we can compute an optimal substitution in a formula with blacklisted in C items, having say 1,800 items and more than 6,000 components in at most 4 seconds. That's really reactive. Great. So also concerning this type of models, we have good news. So we are already not in the plateau of productivity as before. That's why we are interested in them also from an academic point of view, but already in the slope of enlightenment. So already in the process of developing or moving methodologies from academy to industry in a reliable way. Great. So let me just conclude with one. Two considerations. Once again, I really like to point out the importance of using the right models for the right tasks. Using the right models for the right tasks grants advantages in achieving good decision support. Let me skip this detailed say comparison. So technology readiness is not the only reason why we are interested in choosing the right models. There is also a matter of sustainability of these models. In this slide, I have collected some results from the literature about the energy you need to use some models, some AI model, and in particular, this is a so-called transformer model is one of those models used for generative AI. This is the energy needed to train one of these models. It is not one of the last generation. It's a model with 200 million parameters. Current models for say state-of-the-art ones have billions of them. So in this chart, you see the comparison of the energy you need to train one of these models with objects of say the real world. So say concrete objects like a round trip flight from New York to San Francisco. So these numbers are the CO2 equivalent, say weight in CO2 equivalent for either training the transformer or performing such a round trip for one passenger, or the say consumption or production of CO2 in a human life, or the whole life of a US car. And so it's very difficult to compare this type of entities. One is a pure, say, software entity. The other are really hard object entities. However, my claim is we are talking about the same order of magnitude. So also from this point of view, costs and sustainability, the choice of the right model is really of paramount importance. And I guess that's it for my part of the talk. I thank you for your attention. And let me maybe stop sharing. And simply ask maybe if there are some short questions now. Otherwise, I leave the ball to Francesca and defer the questions to the end of the talks. So let me be more specific. Is some of you has some question?
Or maybe they can leave some question in the
Yes.
chat, and then we will dedicate some minutes after Francesca presentation. So
Totally agree.
perfect. So let me introduce Francesca, industrial engineering, specialized in digital technology for businesses with over 17 years of experience, supporting medium and large enterprises in digital transformation project. She focused particularly on data governance, data utilization strategy, and the adoption of artificial intelligence solution. She is the co-founder and CEO of Intellico, a company specialized in designing and developing explainable AI solution for both the manufacturing and service sector, with a specific focus on accelerating product development in cosmetic, chemical, and food industry. So I let the floor to Francesca to explain better this word.
Thank you, Sarah. Thank you, and hello, everybody. It's a pity I cannot see you in the webcam, but at least I can see you, Alberto. So first of all, thank you also, Alberto, for your presentation. I found it very interesting, especially to make a bit of order in what AI is going to be and is evolving today. So let me share the presentations. I think you should see it here now. Okay. Today my contribution will focus on exploring a couple of examples in using AI specifically in the cosmetic industry. About myself, I think, Sarah, you provided already a very good introduction, but in few words, I'm specialized in the introduction of digital technologies for B2B sector. Currently, I'm leading Intellico, which is the company where we basically design and build AI applications for the industrial sector. We also specialize our solutions by using a specific area of techniques, of AI techniques, that go under the label of explainable AI. I thank you, Alberto, has already introduced the graph neural network, which is one of the possibilities we have today in implementing solutions that can provide a good accuracy in the prediction, but that can also let us as user understand what have been the driver and so the criteria that impact the prediction. So basically is the way we see today to overcome the problem of the AI black box that with traditional techniques somehow we have to face. And so as Intellico, we are specialized in this specific area. And in doing this, we applied these techniques both on real case, so providing solutions to company, but also through a research project that we are currently delivering together with some of the most important university we have in Italy, so both Politecnico di Milano and Università degli Studi di Milano. So let's get into the overview. You see here a list of possible AI use case along the cosmetic value chain. So as you've seen, there are different examples that cover supply chain, both upstream and downstreams. Alberto has already shared an example in this area. We have also a list of examples in R&D department and marketing and sales, as well as in operations. So I'm quite confident that you have already heard about predictive maintenance, for example, in the operations area, or optimization of production scheduling. More recently, very interesting applications are emerging in marketing and sales and R&D department, and is on these two areas where I'm going to focus the examples of real use case I'm happy today to share with you. So let's start from the R&D department. I believe we all agree on the fact that fast product development is not just important, but is an imperative for cosmetic companies, especially for who do formulations of recipes. The key questions about how do we create innovative recipe formulation faster and better is an open questions that today it's, let's say, somehow possible to address thanks to artificial intelligence. And I will show you an example on this specific case. So let's think classical situation of an international company. In this case, the company I'm talking about is a manufacturing, so a private label producer in the skincare sector. And this company asked for basically accelerate the possibility to get prediction every time they need to replace specific ingredients in a product. So quite similar again to the first example that Alberto showed to us, but I will show you a couple of, let's say, alternative approach to go through this kind of problem. So the problem was, okay, let's understand if before I get into the real lab, I can have a recommendation, a suggestion, a prediction that suggests me what will be the value of some specific physical properties or also sensory properties, such as skin hydration, pH, or, for example, viscosity. Why these questions? I think you, if some of you work in the sector, I think you are quite familiar with this kind of problem. So currently, the company has to do this at least for 3 different, let's say, reasons. One is related to the market pressure. So every time there is a new trend, and for example, we got a new brief from the marketing department, and there is, let's say, a kind of rush in bringing on the market a product that maybe already exists in our portfolio, but we need to improve and make it align with the new trends. Secondly, problem related to regulatory update. So also in that part, every time the company has to substitute ingredient due to regulatory limitations, and this is quite, let's say it's something that is increasing also due to much more regulation that is entering in the cosmetic sector, somehow following what has already happened in the food sector. And the third area of, let's say, of reasons why this company has to do these formulations quite often is related to supply chain pressure. So I think every time you have to substitute an ingredients because the price has increased, or maybe when you cannot get the ingredient on time due to limitation in transportation. And this is something we had, let's say, went through, especially during the recent time, both during the pandemic, post-pandemic period, and more recently, also due to the war we are facing at the moment. So all these triggers make the formulation process in terms of improving and reviewing the formula something that asks and generate a lot of wasting in time and also in material. The company, the status where we found the company was basically this you see now in the slide. So when a new brief arrived, the formulators started to identify raw materials available on the market, check for regulatory constraints, then started to define, let's say, the baseline of the formula and go ahead in fine-tuning the formula until they get the exactly value of final properties they want to get. And this is done going through what we call a trial and error approach. So by, let's say, trials after trials. So all these ask for at least 6-7+ months in terms of time to market. The number of experiments is, of course, something they cannot control because trials may be really a lot and vary in the way they do the test. And also the waste of material, especially for raw material that have a high cost, may be a problem. So the type of solutions we found was basically a virtual simulator. So think at it as a space where the formulator can define the mix of ingredients or eventually pick up a previous formula that can be similar in the list of ingredients for type and value. And they can do a fine-tuning here, running the simulation, so getting the prediction to a specific property. So let's take the example here of skin hydration prediction. So basically you see the predicted profile about how the hydration is expected to change during the time.
Hello?
And the other graph you got after run the simulations is a graph. This comes from the use of graph neural network, as Alberto was explaining before. So there is the possibility for the formulator to check if the new formula they are working on, so the one with the blue circle, is close to other formula in portfolio. So each node you see there is a formula already archived in the portfolio of the company, and they can basically check if there are clusters that can be also similar in the composition of ingredient, enriching a specific behavior about the skin hydration in this case. So the simulator, let me see if I can show you live. Yeah, I think you should see the video running. Okay, so as you see, you can decide for asking the simulation, pick up an existing formula or eventually start from scratch. This is the case we pick up an existing formula. The formulator can make the change that he thinks or she thinks is necessary, run the simulation, and got in very few seconds the value expected. And about the explainability, you can also ask an explanation to the system. And what I mean here is, for example, let me know how each ingredient is expected to impact the final value of the properties. Okay, so that the formulator can manage and make variations. And you also can get some suggestions about possible alternatives ingredients. So this is, let's say, an example that, as you can imagine, is useful for companies that have a frequent process of, let's say, formulations, especially concerning modification of existing, so improving existing formula, and where you have, let's say, tests that are quite common. And so it's, let's say, kind of repetitive test that you could limit and anticipate by asking to this kind of simulator. Of course, the simulator does not substitute what you do as a formulator in the real lab. So after you got the suggestions from Matilde, what you can see is that if you have tried to, let's say, run 10 alternatives, maybe thanks to Matilde, you can identify the most promising. And so instead of getting to the real lab with 10 alternatives, you can move there with just 3 alternatives that are already closer to the kind of result you want to reach. So in this sense, is a tool that accelerate the time to market, in particularly all the steps you need to do, you need to do before you go into the real lab. So let me show you quite briefly what lies behind. So basically, in doing this, in building kind of this solution, you need usually at least 3 engines. So the first is related to the possibility to apply machine learning, so regression, classification, so this kind of operations on internal source, such as raw material, past formulation. So when you need to, for example, identify similarity or extract non-linear expected reaction, and so predicting, for example, the behavior of a specific composition of ingredient. Then you have a second engine, which is also in this case focused on processing internal source, but in this case is about processing documents, market reports, file Excel, and whatever you have with explicit knowledge tracked by using natural language. So in this case, what is possible to use are large language models. So the kind of models behind, for example, ChatGPT, that I'm sure you all knows, and RAG systems. So the possibility to extract rules and knowledge by processing automatically all this amount of documents. And this is quite useful, for example, if you think to the possibility to automatically check brief and marketing reports or new rules from regulatory documents. Third is the, let's say, NG, when we collapsed all the, it is called APIs in as a technical terms. That means connectors and what we need to use when we want to use external systems. So such as, again, for example, in this case, ChatGPT or Perplexity are 2 good examples. And we ask to these systems to scraping external source in order to, for example, check if some new information has been published on a website of a government, for example. So these are the 3 main components we have behind this kind of solutions. Type of project. So if you want to do a project of this kind, what you should expect to do. So first of all, consider an elapsed time of between 4 and 6 months to build up this kind of solutions. In particular, the first step is the key steps. So it's about data preparation. So at the moment, what you have seen is possible thanks to a training that is necessary to do on historical dataset that the company already has. And in this case, the data preparation is something that involves also a bit of time of the formulator that know very well how the previous experiment has been made. Then you have the second step, which is about to set up the AI model. So is where basically the model is designed, tested, and validated. The validation, how does it come? So the validation is done on what we call initial datasets. So you don't need to use or extract all the amount of data you have in your company, but just an initial data set that is necessary for 2/3 to build the model, and 1/3 is used to test the model. So to do the check and verify is the prediction is going good in accuracy. And then we have a first steps, which is about fine-tuning of the model, feedback collection, and let's say training, a bit of training for the user to learn how to use the AI model library that you can access, for example, in this kind of solutions. And then you are ready for the full adoption. So I'm trying to go a bit fast because I want to show you another examples. But of course, if you have questions, please leave it in the chat and we can manage it at the end of the presentations. So let me go also on this other use case. So this is about marketing team assistance. So let's take the case of a company that produced nail polish and lipstick and needed to understand what could be the new color of the new hair, and so somehow is about trend forecasting, okay, and inventory management as well. So in this case, another example, this is something that can be processed also with platforms such as Matilda, but you can also have a dedicated tool just for the marketing team, where you can basically use system based on large language models to explore both internal knowledge and external knowledge. So in this specific case, for example, there is the possibility to check what are already the information related to current product catalog, sales performance. So what have been the product that has gone better during the previous years. And on the other side, understanding what is happening on the market. So doing market trends analysis, social networks, or publication. The company we follow in this case is a company that has born, the co-founder was at the beginning an influencer. So they have basically a social community quite large. So what we do currently is monitoring what emerges on the community led by the influencer and get the trend from that community in addition to the rest, of course, of the market, and then using this input for the R&D department. So basically this is the application, and also here you will find exactly what is behind of this kind of solutions. So in this case, the engine make three main steps: extraction of key information from purchases. So basically what have been sold in previous years, extraction of marketing insight of the kind I was describing before, and based on this, generation of recommendation for the new product development. So quite simple, let's say. So if I have 2 minutes, I can also show the last. Sarah, if I can go with, or because I have one last examples.
Go.
Okay, thank you. So this is about check regulatory. So basically another example of how it is possible to automate. All the work now is done by R&D professionals in checking and picking up new rules from regulatory, basically. Let's see if I can show you the videos in this case. Yeah. So you see there is in this case the possibility to ask, for example, about what, let's make the case, I want to create a new skincare, as you see here, and I'm planning to add this INCI, so salicylic acid, into the formula. So I'm producing it for Europe, and I need to know what is the maximum concentration. In this case, as you see, you can first get information about the INCI on the right, sorry, you also see that you have internally in your list of ingredients already an ingredient that satisfies that properties, and you got the information about the maximum concentration, you can use for the European market. And in addition, you can also explore and check the source. And this is part of our explainable, let's say, AI philosophy. So in this case, there is the possibility to check and understand how comes the result. What have been the source? Can I trust the source, or I want to put in blacklist some of the source also for future questions I'm going to do. So here you have the possibility to manage the source and basically make your favorite list of source that you want the tool check every time. And of course, you can also provide a feedback about how much you are satisfied, so that the system can continuously learn from your feedback. And last but not least, you can also check what kind of formulation in your portfolio are currently that kind of ingredients, and maybe you need to substitute it or check for the concentration if it's aligned with the regulatory limitation, basically. So I would stop here, Sarah, because I'm afraid probably I was a bit longer than planned. I don't know if there is any questions about these examples. Well, I see still 33 participants, which is a record, I think. You are all there. So probably we can collect the questions also during next days by mail. Sarah, what do you think?
Yes, thank you, everyone. I will wait some minutes if someone has some question and want to open the mic or write something in the chat. Otherwise, we can also collect the email in the next days. Okay, maybe. And I can leave also in the chat our contact, and also the participant will receive the recording of the webinar.
There is a questions? Yeah, so the question is, if we don't have a large set of data, how we can build that type of systems? Definitely good point. So I would separate two areas of what we have seen. So for what concern the prediction, so kind of applications such as the virtual lab you have seen, it's important having at least just to provide you an indicator, a criteria in this. It's useful usually starting at least with 400, 500 trials for the specific category of product on which you want to get the prediction. So this is a good number to start. When I say trials, I mean that this kind of systems learn from both failure and successful tentative you did. So what I mean is that if we provide to these systems just the list of formula already approved, without the trials you did before you got to the approval versions, we cannot get a good accuracy during the training. While if you track the trials, so the step you did and the fine-tuning you did before you got to the approval combination, then you can absolutely start with the volume I shared with you. And this is for the predictive part. While for the interaction with documents and external source, so more related to, for example, check with regulatory or marketing reports and so on, in this case, usually it's simple, because sometimes we have the possibility to prepare the tool using also external source, and usually companies have more information through documents than on tabular data, so as value tracked. So let's say a good way usually for what we are observing is, for example, you can start with the tool related to processing, automating rules and information from document, which is something quite, let's say, I would not say simple, because I don't want to simplify, but it's something that is possible to do in a couple of months, just to give you an idea. While on the predict side, if you do not have enough information, this kind of systems can also be used to start the collection of data in a data-driven view. Because one of the problems today is that sometimes, even if you track informations and data, it's not always ensured that the way you are using to track the data is aligned with the use we need to do for apply AI prediction. So, long story short, even if you do not have the data today, the suggestion is starting with this kind of AI-driven tools, because you can start the collection of the data already with a guardrail to be ready in 6 months then to activate the prediction. So this is suggestions. Yeah, there is other questions. Well, thank you, Salkan, for the questions. So another question is about, what do you think about artificial mirror to select cosmetics before buying? Yeah, definitely a strong future trend. Let's say it's, I think we are not far away to get a very good result from this kind of application. I'm not sure if we are totally ready as a consumer to approach totally this kind of experience, but something is moving very fast, absolutely. So it's don't know on this, Alberto, if you have some inputs to share.
Well, always hard to tell, right? So to the success of a technology before actually deploying it, I also think it's very, very promising, and say from a methodology point of view, the tools you need for this type of applications are I would say even more understood than what you need for decision support, in a sense. So I agree with your analysis, Francesca.
Okay, I think, Sarah, there are no additional questions. I mean, I do not see.
I have leave in the chat an email address to collect some other question if anyone has some. We'll have some in the next days. We will remain available to answer. So thank you for your time and your precious knowledge that you share today with us. As I already said, we will share the recording in the next days to the participant. I also leave here in the chat some of the activity we are conducting in the framework of the project. So keep in contact, keep in touch with us, and thank you for being with us today.
Thank you.
Thank you.
Bye-bye. Thank you, everybody.
Bye-bye.
Bye.
Thank you.
Thank you. Bye.
Okay.
I'm
Thank you very
deleting
much.
people.
Thank you. Very,
Nice
very
talk,
good
Francesca.
presentation.
Very
Thank you very much. Thank you. Very good.
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 I expected most of the attendees were leaving before. It's strange. I mean, it's not so common that.
Yes, io posso mandare un email.
So it's
They
good.
stay until the end of the talk, you mean?
Yeah. I mean, my usually when in other webinar, after 30 minutes, you started to see the counter go down, you know, like predator.
Okay, so it was very
Fine.
good.
Not so good for your self-esteem.
But these ones
No,
are
exactly.
great, yes.
No, but
We maintain the interest of the people, of the persons, yeah, the participants. That's very good. It's always like this. We have a lot of interests, but after not too much participants, but the participants stay until the end, and it's very good. Thank you very much. Thank you. Thank you so much. Thank you. So,
Okay.
Sarah, bye-bye.
That's good.
Thank
See you
you very
soon.
much.
Soon.
See you.
a
Thank
nice
you.
weekend.
Ciao,
Thank you.
ciao.
Bye-bye.
Grazie, ciao.
Ciao, ciao Sara.